Hey, happy Sunday. This is PFG Live, and you found the right place if you were looking for PFG Live. I'm Spencer Webb. We're in the southern part of New Hampshire, where we are currently in a thunderstorm warning because last week's tornado warning was insufficient. Welcome aboard, everybody. We got some chatter going in the Discord server, and let's see what we got. We got Tuck checking in from Buffalo, New York at 69 degrees Fahrenheit, sunny in the Buffalo. Widgetworks from the Edmonton of Alberta is reporting 24 science, mostly cloudy, 45% relative humidity in Snow, Mexico. Josh in southern Manitoba reports from weather station Charlie X-Ray Mike Delta. Winds are currently 170 at 5 knots, temperature 19, dew point 09. That sounds really nice. Evils is in Ghent, Belgium, where he is reporting 26.9 degrees science and 14.9 degrees dew point, probably somewhere under his bench. Josh, our audio checker, is saying, check, check. Daniel F. says hello from a tennis court in central London, UK. If you're standing next to a blue box that says police box, I need to know that. The weather is 18 degrees C and cloudy, but the balls are bouncy and the courts are dry, and that's all that matters. See you in the recording. Welcome, Daniel. Let's say Unix Carbide is with us from Williamsburg in the Brooklyn of New York, 80 degrees Fahrenheit, severe thunderstorm watch. Josh has not been outside yet. We also have CJ Stevens checking in from East Tennessee, where it is 87 with 70% humidity in the backyard. Carl Tauber in the People's Republic of RI says 79 degrees, hot and sticky. I have not been outside, Carl. K-Bonk is sitting in air conditioning, doesn't care what it's like out in Philadelphia, and he says hi. Andrew Deere. Andrew, welcome aboard. Says it's 70 degrees Fahrenheit and partly cloudy in Oregon's Willamette Valley this morning. Nice. And K-Bonk reminds us to use our thumbs. For the button, don't get... Oh, jeez. Sam, you must be a new viewer. Sam in the Boston of Massachusetts says it's 89F, feels like 96, 100% precipitation chance, and also severe thunderstorm watch. I am cozy in my apartment, says Sam. Excellent. Who else is here? I think I got everybody is here right now. Presently in the Discord, give the Discord props here. We have Tucker, Sam, Evils, Carl Tauber, Josh, Widgetworks, Lance K, Robin is with us. Welcome aboard, Robin. Unix Carbide, and Thomas Hardy. Happy Sunday. While I'm thinking about the fact that it's Sunday, allow me to point out that next weekend is Independence Day. So there will be no PFG Live on Independence Day weekend. There may be some random stuff happening, but nothing like this. And you're welcome. We have a few topics to talk about today. Nothing major. I had a nice lunch a few minutes ago while I was watching A-Bomb bash some holes through some A36 steel. That was a lot of fun. I actually haven't completely finished that video, but I believe it ends well. And we had some successes this week in the 3D printer department. A couple of them we'll talk about. And also we're going to talk a little bit about hearing protection. And we were discussing that on our Discord server to some nerdy detail. I know you find that extremely hard to believe, but it's true. And I will pass along some hard-earned knowledge in that department. So let's get underway. I want to welcome. I was kidding. Sam is my kiddo, and Sam is also a, what do you call it? A community manager in the Discord. Sam knows more about Discord than I do, so that's a good thing. Keeps it running. So we're going to go. Oh, guess who just checked in? Machine New Zealand. He says, good morning. 13 degrees, science, humidity 95%. Apparently we have strong winds today, gusting to 100K. Can we translate that? 100 kilometers per hour is what? Is that 50 miles an hour winds? That is 60. Josh says 60-mile-an-hour winds. Holy cow, Machine New Zealand. Well, you stay safe. Don't go outside with anything flying around. And welcome aboard. And I know that you're getting ready to go to work. And have a safe trip to work. So, yeah, let's talk about the 3D printing thing. 60 miles an hour. But 60 miles an hour, that is like crazy. They're not calling it a hurricane or a tornado or anything. It's just 60-mile-an-hour winds. Well, stay safe, folks. And we are approximately the other side of the planet from where this is happening. So we're not seeing it yet, although we're under a severe thunderstorm watch. So many successes in the last week, both on the professional front and fun in the shop front, and we can talk about some of those. In the a little bit of follow up, we do have some follow up topics here today. On solvents in the shop, I got a picture from A-Bomb. Let's see if I could find it. Because there was a question. He was using a CRC product, and I could not remember the name of it. And I'm going to try to find it for you because he sent me a picture of the can he was using. And I was interested because it was different than... Oh, here it is. I found it. It was different than what we were using. And this is, hashtag not sponsored. This is CRC Chlor-Free Universal Degreaser. Now, I know that we started reading some of the safety data sheets and the product data sheets on this stuff. So I don't have a lot to report on this yet, except to say that it is an alternative for a solvent in the shop. And I know A-Bomb's been using this for quite a while, so I just wanted to bring this up. WidgetWorks says it should be a lot like brake clean. And, I haven't had my hands on it yet. Now, the only downside, of course, is it's a product in a spray can, which means it's probably going to add some expense. I use my Sure Shot, which I pressurize myself, and there's other versions of that. But this is another thing to think about. So I just wanted to insert this into the discussion. And if anybody has anything specific to say about that, you could let me know. Let's see. So that was a follow-up from last week. Another follow-up from last week is that we talked about venting a sealed box for application in outdoor environments, marine air environments, rain and pestilence. And I was proposing a vented design. So I went back to my customer and I proposed the vented design versus the hermetically sealed design. And we made what I think is a pragmatic decision. The previous design of this box had been hermetically sealed. In fact, it had this rather hard white epoxy sealing everything, and then the whole thing was painted. The decision was made that we stick with the hermetically sealed box. And I say hermetically because that's, wishful thinking, and the reason was this, and this is, this comes under the heading of engineering versus science. When you have something that works for 30 years, it's like, if you do it again, chances are it'll work for another 30 years. And that was the decision. So we're going fully sealed on that box. I may put in the threaded hole for the vent anyway, and then we'll just, we'll glue in a screw with, the appropriate Loctite and give the customer what the customer is asking for, which I think is a perfectly reasonable thing. We settled on the Loctite 518. That looks really good. I just got some down in the shop, and I'm going to be doing some tests with it. That was a recommendation from WidgetWorks. Now, WidgetWorks does machining in the oil industry, and he's familiar with 518, and it sounds bulletproof. The difference between the Loctite 518 that WidgetWorks is recommending and the material that the previous device was using is that the previous device's material was hard. If I poked it with my scriber, it felt like harder than Delrin, and not as hard as glass. So somewhere in there. I know that's a wide range. The 518 is intended to remain somewhat pliable over time, but basically bulletproof. So stay tuned. We'll give you some updates on that also. Loctite 518. One of the ongoing projects here under the auspices of Antennasis is I have an intern who's doing some projects. The first project was the 3D scanning project. So we've had the Einstar scanner running, and Shaylee has been trying to put together the recipe book for using the Einstar scanner. And it's not trivial. The software, we talked about this last week a little bit, the software is a little hard to understand sometimes. The settings are not obvious, but we started learning some things. One of the things we learned that I can share with you is that there's a setting in the Einstar scanner that says, are you scanning a large object or a small object? And of course, we were starting with small objects, so that switch was in the small object position. Well, after much experimentation, it turns out that small object is not what the switch meant. The switch meant small field of view, and then you could add on to that, considered by the software. So there were problems with maintaining lock to the object. So as you move the scanner around, it would recognize reference points, which could be artificial reference points, like on the bottom, floor that's holding the thing, or it could be on the thing you're scanning itself. Well, as it turns out, the switch should never be in the small object mode, because what it does is it cuts out a whole bunch of area, which is where you get your references from. So that was a big lesson in the last week, and I'm happy to share that with you, is we just leave it in large object mode, and it picks up the most amount of information, and it is able to stay in lock as it's gathering its point cloud. WidgetWorks says small object on most scanners also reduces depth of field. Well, we're experimenting, and this is the first, it's a major win, because as soon as we started ignoring that setting, we started getting really good results. and the software started getting better resolution. And there's another place where you set the spatial resolution that you desire. And if you just set it to very small resolution, but large object mode, that seemed to be the way to go. So big thanks to Shaylee for all the hard work that she's doing. And we're starting to get good results. So hopefully we will be able to publish some fun stuff as a result of this, getting the scanner working. Now, this is the same scanner that the Clow42, James Clow, who, by the way, if you don't subscribe to Clow42 on the YouTube, you should. He's a good guy. We've been corresponding about a few things, and that's one of them. And he had some success with the Einstar scanner, taking data. He was scanning his his grinder so that he could pick up attachment points and plan his automation of his of the grinder that he's working on, the surface grinder. And he also had success, although if you listen, he's got some reservations. So we're trying to put together sort of the real manual for how to use the Einstar, and we'll make that available when we get that going. So that's the update on 3D scanning. It's going pretty well. I don't think we're going to have micron resolution, but the ultimate goal is to scan a thing and then print the thing and have them have a good match. So that's where we're heading. In the Discord server, we have a channel for questions, and if you are able to, and you have questions, you could go over to the Discord server and go under PFG.Live discussion, and there's a thread called 3 questions. And if you want to pop that, you don't have to give 3 questions, but that's what it's called. Because if we have time, we will pull a couple of questions from there and answer them. And there's some good stuff that came in. Sam just linked it in the chat in Discord, so you can go there and check it out. And Sam, I may ask you to copy and paste a question toward the end of the hour, and we'll address some of those. Okay, stand by. Another thing that's been going on is understanding the process of direct-to-buildplate SLA, which is a fancy term for resin printing. And I just looked over at the radar, and we have a frontal passage any minute now. So if I disappear, you'll know why. So most of the time when you think about resin printing and you see resin prints, they look like this. They look like they're printed on supports. This is a piece that I did for John Saunders. If you're on audio, you'll just have to imagine it. You see a bunch of scaffolding holding up the part. And that's typically how we generate SLA parts. But there have been parts that we want to do direct to plate. One of the parts that we have successfully designed direct to build plate is the molly holder. And let's see, I think I have a picture of the molly holder kicking around. Yeah, here it is. So here's the molly holder, if you're watching the video. And the molly holder was a successful direct to plate print. But that was not without some major lessons, and we've talked about those already. I had to make 2 of the edges of that beveled, and then 2 of the edges of that straight 90 degrees, and then it worked fine. So that's how I produce the holder that ships the molybdenum bars in. And but then we went on, and there's some other things that we wanted to print direct to plate. For example, we did I got a couple of examples right here. We did the DAMTEE. This is the Apple AirTag holder for a Yeti tea mug, which I use, by the way. And I use my own product. There's the DAMTEE in action. Okay, and that is printed direct to build plate. Now, you'll notice on the bottom, there's a little groove there. That is one of the secrets to making this work correctly, direct to build plate. And also the little bevel. Let's see if I can point out the bevel. The little bevel here is necessary for giving you a place to pry it off of the build plate. Well, as that process continued, one of the challenges we had was the so-called elephant's foot. So when you print direct to the build plate, the printer will take control of the first few layers. Oh, look who showed up. Test Room 2003, welcome aboard. Checking in late from Oostkapelle, Netherlands. 17 degrees science and 99% relative humidity. It's moist all over. What can I tell you? So the Form 4 printer, as you know, that's my printer. If you dig deep into the settings in the software, it will do some magic stuff for the first 3 or 4 layers. And the very first layer that it prints, you can hear the internal fans spin up and the light source goes to 11. It goes to maximum capacity. And that first layer, it blasts with a very high intensity of the light. And then in subsequent layers, it throttles it back. And then by the time you hit, I think, the 4th layer, it's at sort of whatever normal is for that resin. Well, one of the side effects of that full throttle blast is it actually diffuses a little bit, and the area that cures on the build plate gets a little bigger than programmed. So that's one of the reasons that this happens, and it results in what we call an elephant's foot, which also happens in FDM printing, but for a different reason. Well, sort of for the same reason. Sometimes you'll squish the first layer, right, to get good adhesion, and really it's pretty much the same thing. And in SLA, you're also trying to get good adhesion for different reasons. So despite the fact that the physics are different, the result is the same, that the first layers might be a little big. The second thing that happens, also similar to between FDM and SLA, is that there is a squish. So you actually lose a little bit of height in Z from the squish, and the same thing happens in SLA as in FDM. Again, the physics are a little different. The result is pretty much the same. So we wanted to be able to, and if you look at here's the DAMTEE, and if you look real close, let's see if I can show you, you can actually see a little elephant's foot there. So the challenge was, how do we get rid of the elephant's foot? How do we print directly to the build plate and not have that happen? So the first thought was, and it turns out, spoilers, that's what we did. Oh, here we go. Unix says FDM first layer typically is 120% extrusion. Same principle. Right. So basically, they're pushing out more filament, more melted filament than normal to get that adhesion, and that results in the FDM elephant foot. So the first thing that popped into my mind, spoilers, it also worked, was a simple chamfer. Robin says mini brim. It's like a mini, exactly correct. It's like a mini brim. Right. When you use a brim, you're exacerbating, right? You're adding to that so-called elephant foot. And it's fine. I was talking to Unix Carbide about this week, and Unix says, sometimes you have to take a file to a part to give it its finish, to do the deburring, basically. And I kind of had to laugh, because don't we do that in machining? Of course we do. But the desire is to pop the part off of the build plate and have it done. When you pop a part that's on supports, like this part I did for Saunders, you pop that off the build plate, your work has started. You need to remove these supports and take care of all the little nubbers and stuff. And in fact, Formlabs sells a finishing kit. It's actually pretty nice, with little tools, and they even have I think they have a little powered sander, that you could use for finishing. So I hypothesized that maybe we can make a chamfer on the bottom of a part which will compensate for the elephant's foot. Now you have to be careful, because a chamfer is exactly the thing that if you put it all the way around a part can cause problems in SLA printing. And the physics of that is that you're continually depositing a layer on the plastic, the bottom of the reservoir, and then you're peeling it off, and then you're coming back down just above the reservoir for the next exposure, and you're repeating that. Well, it turns out that a chamfer creates a problem. It does, the peel gets harder and harder to do, not easier and easier to do. And it acts like a suction cup. So chamfers around a periphery are a problem. So there's consideration here. You have to think about this carefully. But a little maybe a little chamfer will work. So that's what I started doing. I started messing around with little chamfers, and eventually, let's see, the best one. So if you're looking on the video, there's how the elephant's foot starts. It's pretty prominent, and there's the best one, the best chamfer. So now it almost looks nice and square, and frankly, it does. And then there's a little overcompensation. So I made this little tool. There's the 3D model, or the first 3D model of it, and there's the final version of it. I made this little tool which looks like a nut, a thin nut with, I don't even remember the diameter of the hole in the middle, maybe 3/8 of an inch. But what this is a hexagonal, hexagonal structure. That's why it looks like a nut, but each edge of it is different. So the first edge is 0. It's a dead perpendicular edge. The next edge, we start putting in a chamfer. Now I have we're on P5 already. I know this comes as a shock to you. There was P1, and here's P2, and then here's P3, and throughout all of these prototypes, I was trying different things, including different angles, non-45 degree chamfers, and including fillets. I have to tell you, the fillets were a complete fail. Reasons? Don't know. Don't care. So we ended up sticking with a 45 degree chamfer. And we got some success. So it turns out that about a 30,000ths chamfer on the bottom of the part. Let's see, this is which one is this? This is P5. So we had 0.1 millimeter, it's on your screen, the picture there, 0.1 millimeter layer height in gray V5 filament, listen to me, resin. And what you do is you take your extremely sensitive instrument called your thumbnail, and you start at the 0 point, and it's a very prominent elephant's foot. And then you start going around the circle. Well, 030 was pretty good, except there was a little teeny lip. And then 0325 was better. And then 035 was also pretty good. So then you put it under the microscope, and what you see, because your fingernail gets fooled, what you see is that it starts off with a reduction in the elephant's foot, but then it starts getting kind of a notch. So you have to decide, which of these do you like best? And it turns out that 0325 was pretty ideal. So I made the little model that gives you one zero side, 4 choices of chamfer. In this case, it went from 030 to 0375, which was definitely beyond the optimum, so we were able to see the optimum. And then the final chamfer was actually a big, deep chamfer, so we can get our pry tool under it to pop it off. Well, then I did a second version of that at a different layer height. This one was 50.05 millimeters, or 50 micron, and a very surprising result happened. Remember, what's the most important words in science? Hey, that's weird. So it turned out that it wanted a little more chamfer for it to be nice. Not much more, little teeny bit. So I think 0325 was the optimum for the 0.1 millimeter, and 035 was the optimum for the 0.05 millimeter. So the short punchline to the whole story is that to get rid of the elephant's foot on this printer with factory settings, with the gray V5 resin at these 2 layer heights, was about a 30 thousandths chamfer, a 45-degree chamfer. Totally fine. I could live with that. And the reason I had to do all this experimenting is because Formlabs gives me this sample print, and it clearly used some technique because it too was really nice. So now I can confirm that, based on comparing what I got to what the sample print from Formlabs was, is that we pretty much found the secret. The next thing we looked at on these test prints was the thickness, because the thickness of this little print was exactly 0.125, exactly with 0 error. It was unbelievable. It was exactly 1/25 thousandths, an eighth of an inch. And then if we take our extremely accurate model 120 Starrett calipers, okay, and we measure the thickness, we could determine what the squish was. Well, it turns out it's about 7 thousandths of an inch. One read 7 thousandths of an inch, and the other one read 8 thousandths of an inch. Okay, so I think we can call it 7 thousandths of an inch. So here's the recipe. The recipe is, and I'm not sure which order to do this in. So the recipe's not fully settled yet. Chamfer 30 to 32, 0325 thousandths. Okay, and then extrude an extra 7 thousandths of an inch, and you should be fine. It should be well within tolerance. So that was the exciting conclusion of the experimenting on the Form 4 this week, and I was very happy about that. And then you just keep all these little sample prints, and you have I use a tie wrap, a little reusable tie wrap, or wire tie, I should say, and you have your elephant's foot figured out. Evils says, will you put the recipe in the show notes? Yes, I will. And you're authorized to bug me about it to make sure I do it. So check the show notes, and I'll put the recipe for you in there, and we'll go from there. So that was killing the elephant's foot, and I was very happy about that. So we have a few things I want to do on the Form 4, which I literally want to just remove it from the plate, go to wash and cure, and be done. The NAS is done on the Form 4. Of course, it was done on the Form 3. Now it's going to be done on the Form 4. And I'm hoping, fingers crossed, that I can come up with a version of the NAS. It might be, a new revision where we could do direct-to-buildplate and have no waste. The other problem with supports, of course, is that there's waste. So as soon as you remove the supports, where does that material go? Into the trash. So it'd be really cool to have the parts designed so there's no waste. And I'm looking forward to that. Robin says, are you saying you need to make the part 7 thousandths thicker than 125 to come out 125? I'm implying that. Have I tested that exactly? No. What I am saying is that a part that was designed to be 125 is, in fact, 7 thousandths short. Now, there's 2 factors here. One is the accuracy, which means there's more to do. There's more to be done. I was talking about this on the Discord this week with some of the guys. I could make a model that has some steps in it so that we could measure steps above the bottom of the build plate to make sure that the incremental accuracy of the machine is good. I haven't done that yet, but I suspect it's okay. And then we could resolve the squish. So if we wanted to get super accurate, or if we need to get super accurate, that's what I would do, Robin. I would do a little step model, measure the steps, and then measure the overall, and then deduce the squish. So yes, I am saying that the part is 7 thousandths. You need to make the part 7 thousandths thicker. Stay tuned. We'll test it, and we will advise. 7 thousandths. Guys, this is a 3D printer. It's crazy. I'm glad we're arguing about thousandths. Well, not arguing, but I'm glad we're talking about thousandths in an SLA printer. That's very exciting. Another thing I wanted to talk about this week a little bit is, and by the way, if you have questions, you are free to pop them into the YouTube chat or pop them into the Discord chat, and we will address them. Robin is setting the example. Evils is setting the example. Good job. Another topic that came up this week is hearing protection. And we did talk a little bit last time about hearing protection. And we talked about, how noise is measured. And I was doing my thing yesterday. I was on the grinder and I'm blowing things off with air. Always use air around the grinder. My watch goes off. My Apple Watch goes off and says, "You need hearing protection." K-Bonk says, "That's darn impressive." Yeah. For 3D printers, I'm happy to be talking about thousandths. So when I'm in the shop, I wear the 3M work tunes, and I know other people also enjoy these. These are big, full size, hearing protectors. And it does two things. It gives me, I think, 27 dB noise attenuation or sound attenuation. Oh, look at that. I'm wearing them out. I just noticed this. Well, now I could prove to you that I actually use these things. I've been using them, constantly for on the order of a year, 2 years. I'll get replacement thingies. But Josh says +1 on the work tunes. Widgetworks says they are nice, but hot and sweaty. That's why I put an air conditioner in the shop. So when I started looking for a way to have hearing protection and have Bluetooth, one of the things I landed on was the IsoTunes Pro. I guess the company IsoTunes. Yeah, the company's isotunes.com. And these are listed as 27 dB noise reduction ratio, noise reduction rating. Robin says he bought replacement pads on Amazon for cheap. Yeah, I don't think I'm going to have trouble getting them. And I'll probably put, 3 pair in stock and worry about it later. But I don't mind wearing them out. I'll tell you that. By the way, before we get off the topic of the full earpieces, I have a long history with, Evils. I'm very proud of you. I see we're going to have a question coming in. Yeah, I'll take your question in a second. Hang on. Well, hang on. Let's bring, is that Tuck? I think Tuck has a question. Hold on a second. We'll just bring Tuck in. Okay, I'm turning on YouTube. I'm sorry, turning on Discord audio and turning on the guest. Tuck, you had a question?
Yeah, so I have a set of these earmuffs, but somehow I can't get them to fit. Do you have any other suggestions?
Well, I would recommend maybe the IsoTunes, because those can go in and they could probably fit, under the hardware, and those could be pretty comfortable.
Oh, under? Oh, I didn't even think of that.
Right? So,
thank you so much.
Take a look at the IsoTunes. Yeah, and they're rated too. They're not just like, earbuds. They're actually real rated noise reduction.
Fantastic. Thanks, Spencer.
Happy to help. Anyway, while we're talking about that, the IsoTunes are a nice noise reducing earplug, okay, with a foam thingy, and it's Bluetooth. And I like these because they stay around your neck. So if you have to pop them out, they just kind of hang there, right? And so I tried them out. Now, here's what I learned. First of all, they work, right? From a noise reduction standpoint, they work. From a Bluetooth standpoint, they work. It's a nice product. And I think I could say that I first learned about these from April Wilkerson on her channel. And I used them for a little while. The problem was, in the shop, I tended to go from, I'd have to go inside, or I'd have to, do things. And I was taking them off and putting them on, and taking them off and putting them on. And I found that the in-ear version was a little bit of a pain in the neck. If, like Tuck, you had to you had to wear it, under your titanium helmet. I could see where that would be a good choice, but I wanted something I could take on and off. That's why I migrated to the Work Tunes. So Robin just posted his favorite is the 3M earplugs. The yellow ones that are 33 dB, foam, bullet, rolled. Hang on. Could we just order that on? Hang on. I'm going to order those. I'm going to order those on Amazon. Yeah, those don't have Bluetooth, but it's worth. Hang on. Okay, hang on. Yeah, come on in. Okay, hey, thanks. All right, these just came in from Amazon. These are the 3M. These are the 3M Classics. And I don't know if that's exactly the same as yours. I think these are not the bullet shape. This is the cylinder shape. I guess I ordered the wrong one. These are listed as 29 dB noise reduction rating. And I guess the bullet ones are claiming 33 dB noise reduction rating. So the foam ones are really cool. Unix says Prime just might not work right in New York City because, well, I don't know. In New Hampshire, that's how fast we get Prime delivery. I don't understand what the question is. So WidgetWorks says it'll work faster if you chew on a blue Sharpie. These are inexpensive, right? This is a box of jeepers. What's the quantity here? 30. These are 30 pairs. Okay, so if they get grungy, you throw them out and you go to another one. They're also very small, so you could have them in your pocket. Do they make them in kids sizes? I don't know, but honestly, these work really well for kids because the way you use them is you roll them tight so they're now small. You push them in and you hold them, and then they expand. And I think they would accommodate, kids' ears pretty good. But those are the ones that we keep around. If you have a guest come to the shop and they're going to help you out for the day, there's a couple of options. One is you just give them those. Yeah, Sam says you just have to make sure they go in ears and not mouth. I think when we talk about kids, we're not talking about kids young enough to eat them. WidgetWorks says, my kids hate in-ear foam plugs. I totally get it. I have a solution for that too. CJ Stevens says, I use Harold Light, L-E-I-G-H-T, electronic ears. Good for in-shop and on the range. So I have a long history with hearing protection because of shooting. And one of the brands I use probably the most is Peltor's. So I bought a bunch of these. These are the slimline Peltors. They're very comfy. and they're small and they're light, but they have a perfectly adequate noise reduction rating. And I keep 2 or 3, I think 3 of these in the shop. Sam, you might have stole one of them, and if you did, I need it back because now you have your shop tunes. But these are great to have for visitors also. These are not Bluetooth. Neither are the foam ones. So CJ Stevens says, we started my youngest. We had to use electronic ears as well. Foam ears didn't work out too well for us. Understood. Evil says, Peltor has kid-sized over-ear. That's absolutely true. I've seen those. Anyway, so we have 2 or 3 sets. Notice how I say that, Sam, 2 or 3. We have 2 or 3 sets of these. So if you come to my shop and you're going to hang around, you have the option of borrowing one of these or getting yourself a set of these, which you get to take home when you're all done. Okay, so these are nice to have for visitors, and I encourage that if you have visitors. A side benefit of if you're a 3D printer person, back when I had my Prusa, I made filament cleaners out of these foam earplugs. So you would slice these to somewhat greater than 50% through the longitudinal, and then take a Kim wipe and put that around the filament, put the foam plug around the filament, around the Kim wipe, and then put a clothespin, the big hole of the clothespin over that combination, and you had a near zero cost filament cleaner. And I ran those when I ran the Prusas, but I don't have Prusas anymore, so I don't do that. I suppose you could probably fit that into the bamboos, but I have not checked. Sam says, my shop tunes are my way of getting to sleep when my housemates are partying late. And you could listen to your favorite podcast. I'm not saying which one it should be, but I'm just saying, favorite. So those are some of the things, those are some of the hearing protection things around here. Also, I have, Robin says, I use slices of them to fill tapped holes in shaft centers to keep the center lube from migrating. That's pretty brilliant, pretty neat. There's a lot of uses for these. The foam, by the way, the foam that's in these is a very good, it's a damping material, right? So there may be some applications for vibration reduction. Just throwing that out there. You guys can play with it and report back. So we'll see. What else do we use for hearing protection? By the way, the headphones, if you're watching the video, I'm wearing a set of headphones. These are not noise reducing headphones. I've stated that before. This is called an open field headphones. So please take care of your hearing. I pinned a post in one of our channels from DBX. He basically cut and pasted a chart of sound pressure levels in dBA, which I'll explain, versus what they are. And it claimed that, I believe, 85 dBA was hearing loss. Like 85 and above, you're at risk. And we should be careful about that. And a hair dryer is right up there. So take care of your hearing. Yeah, K-Bonk says wear them at concerts. And there are concert-specific ones now on the market. So take care of your hearing. And I've seen some of your lathe work, folks, and, that chatter is pretty loud. So you want to put on the... I'm kidding. I'm just kidding. So let's see. We have... I wanted to leave some time for questions. And let's see if we can get them answered. And we got Robin in the wings. So maybe if we get something that's good and juicy, we'll get some input from Robin. So Sam, would you do us the honor of... you could do this on video if you want. You could read us...
Would you like Would you like me to be on mic as well?
Well, you are on mic. You're live.
Now I'm live.
Boston, Massachusetts. Hello. You're on the air.
Should I turn on my camera is the real question.
If you want. So can you read us from the 3 questions thread? Take it from the top and throw some questions out there.
All righty. I will do so.
Thank you.
Let me go find the thread.
We're doing this live, folks.
We are doing this live, and I'm hoping that any lag is not my fault. All right, so let's go for 3 questions.
Just one. Just give us one.
From one of 3 questions. Let's see. You
get to pick whatever.
We've got some stuff from Unix Carbide. Solopreneurship follow-up.
Ooh, okay.
How can one balance the need for customer/IP privacy with the need to discuss ideas and process openly in order to not do dumb things? Working alone with nobody to bounce ideas/plan off of, doesn't that mean that some really bad ideas can happen and do some damage? And I will copy this and put this in the chat.
Thank you. And you could prep the next one similarly, whatever you choose. So that's a really good question. There's 2 pieces to that. One is you want to discuss ideas for a project, which may be, need protection. And then the other one is you want to talk to a customer about the project, and you don't want to give away the farm until they have paid for the farm. So let me address the first one first. Is it really helps to have a cadre of trusted, friends who you could discuss things with and know that they're not going to spill the beans. I know I do. I have a good handful of people that I can call up and say, hey, this is under friend DA, and talk about things and get some pretty good ideas. I'll be honest, several of them are in the chat right now. I know that I've had chats with Robin and said, hey, listen, I got a question for you, and this is under friend DA. And I'm totally comfortable doing that. Same thing with, Unix Carbide and Carl. We can do that. And I think it's important to develop those relationships. And Widgetworks says the rules of Fight Club are, we never talk about Fight Club. So if it's really super sensitive stuff, you could put together your consigliere and actually execute non-disclosure agreements with them, right? So if I went to Robin and said, hey, Robin, could we execute an NDA between us? I haven't asked him that because I don't feel a need to, but I'm pretty sure Robin wouldn't have a problem with that. Similarly, vice versa, and the same thing for any one of a number of my friends. So that's one way to protect it if you feel you need to, but then you have somebody you can talk to about technical stuff. But the other way is what happens when a customer comes to you, and this is the hardest thing. Customer comes to you and says, hey, I need some help. I think we want to retain you, hire you to design a system /widget /whatever to do this thing. And then at that moment, you realize you know exactly how to solve that problem. Like you already know how to solve that problem. And you also know that nobody else knows how to solve that problem. This is a challenge because you have to, if you want to get paid, you have to, at that moment, keep your mouth shut. And you have to have a discussion that does not disclose the secret. And really, you really have to understand the question more. And ultimately you could say things to your client that indicates that this is an area of expertise that you think you could contribute to. Would they be willing to sign an NDA? So you could have somebody who is not yet a client. They have not signed you up. You are not under contract to them, but you can still execute an NDA. And at that point, you may choose to discuss what you have on your mind, and they are bound by the NDA. So that's one approach. As a consultant, it's kind of hard not to give away the farm. Let me put it a different way. As a subject matter expert, it's really hard to not give away the farm on the first contact, unless you mean to. So that's one way to think about it. So an NDA, a non-disclosure agreement, is a contract. Okay, and I have a few rules about a contract. Yes, WidgetWorks says an NDA needs to be enforced to mean anything. Correct. So I have two rules about a contract. Rule number one, never do business without a contract. Rule number two, never sign a contract with anybody with whom you feel you need to have that contract. What do I mean by that? I have a friend, I've lost touch with him actually. He lives or lived up in Vermont, and we did some business together. I designed a bunch of stuff for his company, and we had a one-pager, like three sentences on a piece of paper, and we signed it, and that was our contract. And we both put it in a desk drawer and didn't look at it for 20 years. Meanwhile, in those 20 years, he was sending me checks steadily until the product line died. Perfect example of a guy that I didn't feel I ever needed a contract with. He was that good of a friend, and we had a contract. Case number two. I had a guy I signed a contract with for development of a product. Without going into too many details, this guy was very, full of himself. He thinks he's the captain of industry. There's about 3 people out there. As soon as I say that, they know exactly who I'm talking about. And we negotiated, it was a lot of negotiating, a contract. And we went to sign this contract, and I looked across the table, and we signed the contract, and he handed me a check. It was part of the contract. And at that moment, I looked at this guy, I looked him in the hairy eyeballs, and I said, we're going to have a problem. And you know what? In retrospect, we had a problem. Now, we amicably resolved that problem. But if it weren't for that contract that was signed, sealed, legally valid, and, as WidgetWorks is pointing out, and my willingness and intent to enforce that contract, it would have been a bad scene, because I had to execute some things the hard way. I'll just leave it at that. One more question. Go.
All right. Because we only have so much time, this one was... There's 2 options. We can either do Voyager spacecraft questions or food questions.
Let's go with Voyager. We'll do food in the after show.
Also from Unix Carbide, what sort of antenna is used on the Voyager 1 spacecraft? How long does it take for a message to reach us from Voyager 1, and how long do you think that sucker will continue to operate?
So I don't remember the time right now. I think the round trip time is 22 hours. So basically, if you send a command, I know Evils is going to come up with the Josh is typing. You send a command and you don't get confirmation of the command for something like 22 hours, and that's just 90% of that is the speed of light. Yeah, no, not that Voyager, Josh. That's
Not quite.
not that Voyager. The other Voyager.
Wrong type of nerdy.
Yeah. So if you're not on top of this stuff, Voyager 1 was launched in the 70s. It has been delivering information to us since then. It is the furthest man-made object from Earth in existence. Link in the Discord, voyager.jpl.nasa.gov. And there was a problem a couple of months ago where it started sending back gibberish. They figured out it was a memory chip after much analysis. They uploaded new software. They patched the software from billions of miles away. The patch worked. And as of now, Voyager is sending back valid science data again. It is unbelievable. But I digress.
So if you actually go to the voyagerjpl.nasa.gov, they have a link to like the spacecraft itself, and under there is instruments. And it turns out they have a specific link about a high gain antenna.
Right.
And
so,
now
okay.
Now I feel like we're gonna get a lecture.
Now, I hope you're comfortable. I won't make this too long because I know we're at the top of the hour. But there's a number of antennas on the spacecraft. One of them, let me put it this way. There's a number of antennas which are intended to communicate back to Earth. One of them is a small, low gain, kind of boring antenna that's really only for, at this point, an emergency. And I don't even think it may not even be possible to hear that antenna. I'd have to do a little research. But the main antenna is, I think, about a 2-meter parabolic reflector antenna. And that's the one that the spacecraft keeps pointed at Earth and sends back data. I actually did an analysis of this a while ago, and frankly, I apologize. I don't remember the exact numbers. It's on the order of 10 gigahertz frequencies, and it's a dish antenna, a parabolic dish antenna with a prime focal feed, meaning the feed is in the middle. If you think about your standard direct-TV antenna, that's called an offset fed antenna. And right now, the baud rate, the bits per second that they're capable of communicating to Earth with, is on the order of 20 bits per second, I think, which is, tells you how weak that signal is. But it's about a 6-foot parabolic dish antenna. And of course, that antenna unfolded, and it's been unfolded since the 70s, and it's still cranking away. Did I answer the question, Sam?
How long does it take a message? We answered that. What sort of antenna? We answered that. How long do you think that sucker will continue to operate?
Oh my God.
My
Holy crap. Those engineers back in the 70s that put that thing together at JPL, awesome dudes. And they're retiring and they're aging out right now. They really are. And one of the lead principal guy, forgive me, I don't remember his name, passed away a couple of months ago. And those guys are just awesome. The fact that they were able to diagnose a memory chip failure, upload new software, and then have it reboot and say, yeah, okay, I'm back. I don't even know what to say. Microsoft can't do that. Okay? I just tried to... hang on, Sam. I just tried to update my Windows computer, and there's an update that can't be done. It keeps failing over and over again. And it's been doing it for, 8 to 10 months, Microsoft. I could have walked to Redmond and back and knocked on their door in the time it's taken them to not fix that update problem. But we can update the Voyager 1 spacecraft billions of miles away and have it work and continue getting on with science business. Microsoft, what the hell's wrong with you? Okay, moving on.
Do you want to march down to
No, I'm good.
Kendall?
I'm good. Hang on. I need a drink.
Yeah.
There he is, Ed Stone. That's right. Ed Stone, former director of JPL. He's been on the project since day one. What a guy, and he passed away recently.
What was the movie? I don't think this wasn't the Voyager, but there's a really good movie about NASA. Hidden Figures.
Hidden Figures.
And you want me
awesome.
to watch it still?
Oh, Hidden Figures is an awesome movie. There you go. There's the movie.
So,
there's the movie recommendation for the podcast. Hidden Figures. Hey, Sam. Thank you for your help. We'll see you in the after show. Okay.
I have questions about food.
It's
definitely not because I'm hungry.
Probably not. Okay. Good enough. With that, I think we cleared out all the questions. Hey, thanks for being here, everybody. CJ Stevens says great information. Thank you, sir. That was fun. We're going to try to do that every week. We'll pick questions from the Discord server. That was a good one, and we'll do more. So we'll try to get them all in. Hey, you know what the most important thing is? That you find something flat. If you don't have something flat, go over to pfgstones.com and get yourself something flat or something that'll help you keep something else flat, because flat is important. Next week is the Independence Day weekend. We will not be having a live. We will have it the week after. If you don't know what a Discord server is, find out. Look in my YouTube library. There's a video called How to Get on the Discord Server. Come join us. We have a lot of fun, a lot of discussions, a lot of problems get solved. And Sam says like, comment, subscribe, and overthrow your robot overlords. And with that, I'll remind you to get flat and stay flat. And we'll see you next week.